Hello, ladies and gentlemen. The question is right there on the board. What is the magnitude and direction of the force that must be added to the following 4 forces so that the resultant of the 5 forces is 0? You are given that force A is that, force B, force C, and force D. So this, ladies and gentlemen, that's where you'll be able to use a component method to solve the vectors. I did a video before for this, and I could not finish everything. So the reason why I decided to redo the video is because I want to take care of the parts that I could not finish. Okay, so let's get to work. So when you're using a component method, first thing that you have to know is you need to come up with a diagram first. A diagram is very, very, very important. So let's try to come up with a diagram. You have your Cartesian plane here. So let me just call it your cardinal points here, whereby this is your north, south, east, then west. So you are told that A, vector A, it's 100 newtons, 30 degrees west of south. So when they say west of south, it means you are standing at the south. So now we are going west. That's west of south. You are at south, supposed to go west. So west of south, you go to south, then you move towards west. So it means your angle will emerge from here. I'm just going to assume that this is going to be what? My A. So my A, which is equal to 100 newtons, is going to be this, and the angle will be 30 degrees as indicated there. Hopefully it can be seen. Unfortunately it's very small, but we don't have a choice. Then we go to vector B. Vector B, they are saying it's 200 newtons, 37 degrees south of east, which means you are at east. Then you move to the south, south of east. So this is our east. So you're supposed to move towards south, somewhere here. Then you assume that that's where your 37 degrees is, and this will give you your B. That's 200 newtons, and the angle, they said it's 37 degrees, like this. Then you move on to your C. That's 200 newtons, 37 degrees east of north, which means you are at your north going to the east. How many degrees? 37 as well. So it's something like this. Then let's assume 37 is here. So you have your C here, which is equal to 200 newtons as well, and the angle is 37 degrees. Then the last one, you have what? D, which is 200, and you have 30 degrees west of north, which means you are at the north. You are at the north going to the west. North going to the west, which means the north of west. West of north. You are here. Then you move 30 degrees. I'm going to peg my 30 degrees somewhere here. Then I'll put a line. And this line will be my D, which is equal to 200 newtons. And the angle is 30 degrees Celsius. So if I'm to represent on the diagram, this is what is expected, ladies and gentlemen. This is what is expected. So now, I have to come up with a vector component method. So using the information that is here, I'm now going to come up with a diagram that has something like, here I will be having a vector, here I will be having an angle, which I can call theta. Here I will be having x component, and here I'll be having my y component. So I'll have a smaller Nyana table like this. Yeah, I'll have something like this. Hopefully it's visible. Okay, so for my vector A, which is equal to 100 newtons, my vector B, 200 newtons, my vector C, 200 newtons, and my vector D, which is also 200 newtons. The angle theta there, it's for A. Let's go to A. My A is here, and I have my angle 30 degrees. Before you put in anything, you should remember the laws of the quadrants. This is your first quadrant, your second quadrant, your third quadrant, and your fourth quadrant. So in the first quadrant, we have theta. You take the angle as it is, as long as it's moving from this side going up. In the second quadrant, you take what? The angle must be between theta, and it must be between 90 degrees and 180. Therefore, the rule here is 180 minus theta. The rule here, it's what? It's either 270 plus theta. Let's go with that. It's 270 plus theta. Here it's 360 minus theta. So you expect the angle here to be between 0 and 90. You expect the angle here between 90 and 180. You expect the angle here between 180 and 360 and 270. You expect here to be between 270 and 360 degrees. Nothing less. Okay. So now, using these same rules in each quadrant, when we come to our A here, which is in third quadrant says the angle that we are supposed to get here must be greater than 180 and less than 360. Sorry, less than or equal to 270. So this angle 30 degrees that we have in third quadrant, it's wrong. Why? Because you can't expect to have an angle that is less than 180 in third quadrant. Therefore, something must be done. So the actual angle here, it's going to be what? You can the angle that we are looking for in this quadrant is this angle. Remember, everything starts from here all the way. So we are looking for this angle that is marked in red. So the simplest way to get that angle is to just say, since all this is 270, is to just say 270 minus theta. Oh, sorry, I wrote something wrong here. I'm so sorry. This quadrant here, it's 180 plus theta. This one, it's 180 plus theta. Or, yeah, it's 180 plus theta. This quadrant. Sorry, I wrote something wrong. So this angle that we want is this one that is in red. We are going to disregard the one that is in black. Why? Because we don't expect to have an angle that is less than 180 in third quadrant. Thank you. So the final angle now will be, what is it? 270 minus 30 degrees, which will give us 240 degrees. So your x component will be 100 cos 240. Your y component will be 100 sine 240. Hopefully it's making sense. Now, for B, our B is here, and the angle for B is 37 degrees Celsius, and it's in the fourth quadrant, of which we said in the fourth quadrant you cannot expect, let me use this rule. I'm going to use 270 plus theta, just to simplify things. Right, so in this quadrant you expect your angle to be greater than 270 and not less than that. Therefore, if you have an angle like 37 degrees here, it means it's wrong. It's wrong. Therefore, the right angle must be calculated. The angle that we need under normal circumstances, it's this angle. all the way up to this line. If we are to take it from this side, it must be negative. Nah? But if we are to take the actual angle, it must be this covered area by this dotted line. So how can we get that angle? You can see that it's actually 270 up to this point plus this angle. Okay? But we do not know what this angle is. But we know that this one is 90 degrees. So if you can say 90 minus 37, you're going to get this angle. So 90 minus 37, what do we get? You're going to get 53. So it means this angle here is 53. It's 53. So it's either you are just going to say 270 plus 53, you can still get your answer, or you are just going to say 360 for the whole minus 37. It's still the same thing. 360 minus 37, let's just use that. So 360 minus 37, and you will get your answer there as what? 323. So you can either say 270 plus 53, you can still get the same answer, or 360 minus this one, you can still get the same answer. Okay, then your horizontal component will be 200 cos 323. Here you have 200 sine 323. Now we go to C. C is here, and the angle is 37 degrees in the first quadrant. The angle now, I said in the first quadrant, you start counting your angle from the positive x direction anti-clockwise. Here they are counting clockwise, which means this angle is also wrong. We can't expect to have an angle like this in the first quadrant. The actual angle that is needed in this first quadrant is this one. This one right here. This is the angle that we need. So it's simply 90 degrees minus 37 degrees. What do we get? 90 minus 37, 53. Or we once calculated something like that there. So it's 53 degrees, which is the angle that we want. So your x comp will be 200 cos 53. Then your y comp will be 200 sine 53, like this. Hopefully it's also still visible. Well, for D is here, and the angle for D we are given 30. 30, it's a way less than the angle that is expected here. Here. So the angle that we need here is either it's between 90 and 180. So there are two rules that you can use there. You can either use 90 plus theta. You can still get the same answer. So now, since we have 30 degrees, the actual angle that we need in that quadrant, it's this one right here. This one, up to this line. So you need 90, then you add theta. So it's going to be 90 plus 30, and that will give you 120 degrees. So that's the actual angle that you need for D. So your D x component will be 200 cos 120, and this one will be 200 sine 120 degrees, like this. Sorry for that. Okay, so now we have to calculate and get the values for x and y comp for each. So for the first one, we are going to punch 100 cos 240, and we will get that as our answer, negative 50. Please do so on your calculator as well, so that we can check and see if we are getting the same answer. Then we have 100 sine 240. We are getting negative 86.6. Negative 86.6. Then at the bottom there, we have 200 cos 323. We have 159.7. Then here we have what? 200 sine 323. You have negative 120.4. Then you have 200 cos 53. You have 120.4. Then you have 200 sine 53. You have 159.7. Okay. Then you have 200 cos 120. You have negative 100. Then you have 200 sine 120. You have 173.2. So this is what we have. Hopefully it's visible. I would like to think that it's visible. So now, since our question is saying what is the magnitude and direction of the force that must be added to the following 4 forces so that the resultant of the 5 forces is 0. So it means we have an extra force that we must add here that I'm going to call E. So I'm going to call it force E. And my force E must have theta, which I will call E theta. Then it must have an X component, which I'm going to call EX. It must also have a Y component, which I'm going to call EY, like this. Okay, so what it means is that if you add force A, B, C, D, and E, the resultant is going to be 0. Okay, that's what this means. So let me copy the answers here. Nah? Because I'm going to erase these things. So I'm going to add all the X components and get one value, and all the Y components and get one value. So for X components, I'm going to say minus 50 plus 159.7 plus 120.4 minus 100. So the final answer that I get there is 130.1. So X comp, the total was 130.1. Y comp, I'm going to add this. So I have negative 86.1.6 plus 159.7 minus 120.4 plus 173.2, and this will give me 125.9. Right, so this is what we have. So I'm going to erase the diagram and this, then we'll be left with this only, because that's what we are going to use. Okay, so what the question is saying, if you add, let's say your A, X plus your B, X plus your C, X plus your D, X plus your E, X, the answer is 0. The same again if you add your A, Y plus your A, your B, y plus your c, y plus your d, y plus your e, y. The answer that you are going to get is 0. So remember, when I added all these up to this one, I got what I call an x comp. Here, if you add all these, this is what you're going to get. So I'm just going to write 130 here, 0.1 plus ex. This is equal to 0. Therefore, ex is equal to negative 130.1. So if you take this to the other side, it will give you 130.1 newtons. That's your ex. We are going to look for ey. Again, when I added these up to this one, I got 125.9. So here, all these, they represent 125.9 plus ey, they are equal to 0. Therefore, ey is equal to negative 125.9 newtons. I'm sure we are together. Nah? So I'm going to erase these now since I'm no longer going to use them. I have found what is it? The x component and the y component of the additional force. Now I need the magnitude. Okay? I'm no longer going to use this. So I'm going to copy ex. Ex is equal to negative 130.1 newton. Then ey is equal to negative 125.9 newtons. This is 5, sorry. Okay. So I'm going to erase this. Now, for us to be able to calculate magnitude, we know most that E is given by square root of ex squared plus ey squared. We know this most. This is how you calculate the magnitude. So this is equivalent to ex, that's negative 130.1. Then we square this plus ey, that's negative 125.9. Then we square this. If we do that, what are we going to get? Square root of 130.9, sorry, 0.1. Then I square that plus 125.9. Then I square that. My answer here is 181 newtons. So E it's 181 newtons. So that's the magnitude. So you have managed to answer the first part. Now you need the second part, the direction. Now, direction is given by an angle, which is a tan inverse of EY over EX. This is how you find your direction. So if we are to plug in the details here, you have tan inverse of your EY, that's negative 125.9 divided by your EX, that's negative 130.1, like this. So if you punch on your calculator, you are going to get tan inverse of what? 125.9. Remember, the negative signs are going to cancel each other. So your answer will be left without a negative. So if you punch very well on your calculator, you're going to get 44 degrees. It's actually 44.1 degrees. So this is the direction. Now, if you want to be, since we got what? 44.1 degrees. So, once again, sorry for this. So you have your magnitude as what? 181 newtons, and your direction as what? 44.1 degrees. If you are very much if you are that kind of a person who wants to explore and give detail to everything, né? What you have seen is a Cartesian plane like this, whereby your EX was negative 1/3, which means EX is the force in the x-axis, which means your EX was in this direction here. And then your EY was negative as well, was negative 125, if you still remember, which means it's taking this direction of the Cartesian plane. Therefore, your angle 44.1, you are expecting to have it in this quadrant. You are expecting to have it in this quadrant. 44.1. So this is the angle, something like this, 44.1 degrees. Because in this quadrant, that's where you have a negative x and a negative y. So the angle, it's here. But if you are following what I was saying when I was introducing the angles on that diagram that I've drawn at first, I said in this quadrant, you can't expect to have an angle that is less than 180. For example, you have 44 degrees point 1. This angle right here is wrong. So the actual angle here, I said in this quadrant, you use what? 180 plus theta, or 270, or 270 minus theta to get the actual angle. So you use one of these. So the actual angle for the direction, it's given by 270 degrees minus theta. But in this case, this is the theta. So let's not use this one. Let's use the first one. Sorry for that. So the actual angle now, the actual direction, it's given by 180 degrees, which is from this point up to this point, plus, because what we need is up to this line. So this whole thing up to this line is what we need. So the actual angle is given by 180 plus 44.1 degrees. And that will give us what? Plus 180, around 224.1 degrees. So this is now the direction. So this is the direction. But if you choose to remain with your 44.1 degrees as your direction, this is what you have to do. You have to write direction is equal to 44.1 degrees. In brackets, you write third quadrant, so that the invigilator or whoever, the marker or whatever, will be able to see that, okay, this angle is in the third quadrant, therefore it can't be 44.1. Okay, but this is the actual angle. But if you choose to end here, just indicate that the angle is in the third quadrant. Okay, I think I am clear. I think I'm clear enough. Thank you so much for your attention.